Hello everyone, welcome to Infostonsystems channel. This is David. We are now in the 6th episode of Semiconductors series. So the last 5 episodes, we were talking about what is semiconductor and what is transistor, what is mechanism behind the transistor. So this is all we have discussed in the last 5 episodes. So if you haven't watched, please go ahead and watch the last 5 episodes and continue to watch the 6th episode as well. So today, we're going to have a talk about a very important topic, logic gate. What is logic gates? What is the meaning of logic? Logic means a set of rules. So if you have your own organization, or if you have a company, you should have proper rules, regulations, responsibilities, right? So everyone has to follow that. Everyone has to follow their responsibilities. Everyone has to follow their hierarchy. Then only your company's objective shall be met. Same like that, if you're going to travel on the road, you should follow the traffic rules. So if everyone follow the traffic rules, then you would reach your destiny on time. So same like that, our Indian government, every government has constitution, so that every politician has to follow and govern the nation based on the constitution, right? So that set of rules helps to everyone go on the same track, on the same page. So same like that, in computer processor, the transistor has to work based on the logic. Whatever the input you give, what the expected output shall come to you, right? So for that, you need a logic formula that's called logic gate. So when I'm going to talk about logic, main set of rules, there are going to be 3 Boolean logic. One is AND, the next one is OR, and third one is NOT. AND, OR, NOT. These all the Boolean logic will work in the logic gate. So we already have talked about how the machine will understand the code. Machine cannot understand the human words or human written programming languages. Only the machine can understand either it will on or it will off. So it will understand only zeros and ones. 0 means on, 0 means off, and 1 means on. So the machine only understand those only 2 digits, 0 or 1s. Then we already talked about the 2nd episode, right? So these all are binaries, like if it is 8 zeros and 1s, that means it's gonna be 8-bit, because 1 digit of 0, either 0 or 1, gonna be called 1 bit. So 8 zeros and 1s is a 8-bit, and 16 zeros and 1s is a 16-bit. So like whenever you're going to buy a computer, you may see that 2 variants of computer. One is 8-bit processor and another one is 16-bit processor. So what is the difference between both 8-bit and 16-bit? So if you want to see the comparison between that, then watch this episode. That will give you the understanding what is 8-bit and what is 16-bit. Let's go ahead. Let's talk about AND gate. AND gate, there is going to be 2 inputs, A, B, and 1 output. If you give 0 to A and B, then output gonna be 0. If you give input 0 to A but 1 to B, then still the output is gonna be 0. If you give input 1 to A, 0 to B, then still the output gonna be 0. If you give input 1 to A and also give input 1 to B, then the output will be 1. So AND gate, if both inputs are 1, then only that output gonna be 1. So let's see the OR gate. In OR gate, there is gonna be 2 inputs, A and B. If you give input 0 to A and 0 to B, then the output is 0. If you give one either A and B, like for example, if you give input 0 to A, 1 to B, then the output is 1. If you give 1 to input A and 0 to input B, then the output gonna be 1. So if you give input 1 to A and also if you give input 1 to B, then output is also gonna be 1. So the OR gate, either one input is 1, then the output will be 1. If both inputs are 1 also, then output will be 1. So now let's talk about NOT gate. Before we're going to talk about NOT gate, let's go ahead and see this comedy.
நீங்க ஓகே சொன்னா தான் நான் விடணும் அவ்வளவுதானே? ஆமா, கவலைப்படாதீங்க பாஸ். நீங்க ஓகே சொன்னா தான் நான் விடுவேன். ஓகே? ஓகே.
In this comedy, like you see that, right? A person named called Cobol. The Cobol is do whatever you say, he will do opposite. So that same like that this NOT gate will do. Whatever the input you give, it will inverse that and give you the output. For example, if you give input 0, then output will be 1. If you give input 1, then output will be 0. So it will only operate in the opposite side. Like if you give input 1, then it is going to be the inversal answer, right? So this is called NOT gate. Now what we have to do is, we're going to combine AND gate followed by NOT gate. If you see here in the screen, AND followed by NOT, whatever the output you got from AND gate, all the output will be inversed and it will be opposite to the input. For example, if you give both input 1, then the AND gate output is 1. But if you're going to give that output as an input of NOT, then output is 0. So if you combine together, there is called another gate. The name of the gate is NAND gate. So the NAND gate is just combine followed by AND followed by NOT is a NAND gate. Same like that, if you keep NOT gate followed by OR gate followed by NOT, then it's gonna be NOT gate, which means whatever the output you got from OR gate, that when you that output is given to a NOT gate, then all the outputs gonna be inversal output. So that's called NOR gate. So now we have seen AND, NOR, NOT, NAND, and NOR, right? Let's talk about another gate. Before that, I'm going to give you one simple assignment to you, okay? So I'm going to give you that is if either one input is 0, if either one input is 1, then output should be 1. If both input is 1, the output is 0. How you make that? Think about it. Like let me tell you again. If either one input is 1, then output must be 1. If both inputs are 1, then output must be 0. How you will make that? So for that, you have to arrange the gate to meet your expectations, because you cannot use AND gate, because AND gate, if you give both inputs are 1, then output will be 1. We don't want that. In OR gate, either one input if you give, that output will be 1, that's okay. But if you give input 1 to both inputs, then output will be 1. We don't want 1, we need 0. We cannot use OR either. So for that, you should follow this arrangements as you see in the screen. Like here you can see the gates X1. So there are two AND gates, X1 and X2, and one NOT gate, that is Z, and one OR gate, that is called Y. So you have to arrange these, arrange the gate like this, then your expected outcome will come, expected output will come, okay? So assume that if you're gonna give input common to both AND and OR, X1 and Y, we are not giving both separate input. The one combined input we're going to give to X1 and Y. If you give A 1 and B 0, what will happen? So both AND and OR is that. So first that input will be given to, just talk about AND line, okay? So AND, that will A 1 and 0 will be, output will be 0, because AND we need both input only will be 1. So here only one input is given, then that will be output will be 1. That output 1 will be given to NOT gate. The NOT will reverse the output. That means again the 0 will be converted to 1. That 1 again will be given to X2 AND gate. So okay, then now talk about that Y. So here also you're going to give A, B. There is one input is 1. So output also will be 1. The 1 will be given to AND gate. So now AND gate received and I mean talking about the X2. X2 AND gate receive two inputs is 1, then it's gonna be output is 1. So if you put both inputs are 1, then AND gate will turn that 1 to X2 and X2 output will be 1. That NOT will, that will inverse that 1 to 0. Then also that 1 will come out of Y. That 1 also will be given to X2 AND gate. Here you see that both input is not 1, so then output gonna be 0. This is the way you can see the expected output. So if you arrange this and keep it in one gate, that gate called XOR, exclusive OR. So this is you see the screen, right? These are all the arrangements combined together, and we're going to give the name that is called XOR. XOR means the same arrangement you see in the screen. So XOR gate say what that way. If you give both zeros, then output is 0. If either one input is 1, then output is 1. But if you give two inputs is 0, two inputs are 1, then output will be 0. So you see that expected output now. Now let's talk about another gate that is called XNOR gate. What is XNOR gate? So if you see the XOR gate, right? If you keep XOR gate followed by COBOL, means NOT gate. If you keep COBOL followed by XOR, that is called XNOR gate. What does that mean? Whatever output you got from XOR gate, it will be inverted to the opposite output. Okay. So XOR output we already know, right? How that works. So all the output will be inverted to inverted output. Then it's XOR gate. Means we are keeping NOT gate followed by XOR gate. These are all the gates, same like AND, NOR, NOT, NAND, XOR, XNOR. These are all the logic gates works in the processor. That is called all the compute processing is working well. This is the way all the computer processor works behind the logic gate. So now we have just seen the example with very simple input zeros and ones. But computer works with the complex input, like it will be working under 8-bit input, means 8 zeros and ones. So which means 8 bit of data, it will work with 8 bit of data. So if the processor is 16-bit, then it will work with the 16 bit of data. So that is why the comparison will be in both 8-bit and 16-bit. That's gonna be a little complex. So if you are working in the highest computer, and nowadays the modern computer, everything's coming with the 16-bit processor. So because we need a highest performance, right? So for the gaming or everything, so we need 16-bit. So now you understand the importance of the zeros and ones in binary working with logic gates. So hope you now understand the logic gates, what is the logic behind, right? So in the next episode, we're going to talk about the real-time example, how smartphone works with a simple logic and or not. I'm going to give you experimental demo. Then you will have a better understanding, right? Then followed by that, we will also talk about how we're going to programmatically operate the computer processor, right? So we will see that as well. Until then, stay tuned. Thank you.